welcome back. We are excited to be back with you guys to kind of show you another demonstration. Today we're going to be investigating some emission spectrum of 6 different elements. In order to do that, we need these light boxes and we need some Prism Glasses.
Yeah.
Oh yeah. I'm looking really
Let's do it. Mr. Pilcher, want to get the lights?
Yeah, I just installed a clapper, you guys.
Woo. So the first thing that we're going to do is we're going to put some glasses on. What you have on now are called prism glasses, and they are taking the white light that you see and they are refracting it into the prisms that you see here.
So this is with the goggles on.
Goggles off.
Here's what the goggles off looks like, just regular white light. Then when you put those goggles on, this is what you're looking at. Got a nice spectrum there.
Awesome. So when you see the lights coming out of these 3 emission tubes, you will see the light coming in and then it's being bent, and it should give you a barcode looking image.
So the first sample we're going to test here today is a tube of hydrogen gas. Okay, so remember, this is the element that Bohr's model predicted the best. Okay, so what I'm going to do is I'm going to flip the switch on. It's going to send a bunch of electrical energy into this gas. And what's going to happen is those electrons in there, they're going to become excited temporarily. They're going to jump up. They're going to fall back down. As they fall back down, they're going to release light. So with the glasses off, all those combinations of falls by electrons look like this. And then when we put those glasses on, we can see the different individual falls of electrons. So you see a nice little barcode emission spectrum. Now you may see a little bit of red in that barcode. Now red is the lowest level energy, so that means that's an electron that's fallen not that far. So maybe it went from the second ring down to the Miss Bay's having problems.
Sorry.
So maybe it's falling from the second ring down to the first ring. So that's going to be a pretty small fall. Not that much energy is being given off by that photon, hence the red light. But you may also see some blues and some violets. Those are going to be an electron that went pretty far up, maybe like the 4th ring, and it's going to have a pretty big fall back down to its ground state. So its excited state, maybe many rings up. Its ground state is going to have a big drop off, and so you're going to see some pretty high energy, those violets and those blues.
All right, so the next sample we're going to do is helium. This has 2 protons and 2 electrons. So we're going to have a different color and a different barcode than we did with the hydrogen. So again, we'll start first. This is the color with it without the glasses. And then when you put the glasses on, you should be seeing a different barcode than you did before. So what you're seeing here now is you're seeing the similar red color down here at the bottom. There's a nice another yellow line in here, and there's a few more because there are more electrons jumping and falling. Again, when they gain energy, they jump far away from the nucleus, and then they fall back down, and as they fall back down, you see this different line spectrum. Perfect. So this should look different than the one you just saw in hydrogen.
The next one we're going to show you here is going to be neon. Now neon has more electrons, 10 electrons, 10 protons. Those 10 protons pull harder. They're going to pull those energy layers closer to our nucleus. And here's what a neon's going to look like without the glasses. And if we add the glasses in, you should see a lot more color bars in here. A lot more color bars, again, because we have more energy levels getting compressed into a space that we can see them. All right. And then just kind of like what we were doing before, if we look here up on our screen, we have, again, a lot more energy bars here, right? So our electron, it can hop down. Right? It doesn't have to go as far. The energy levels are compressed. And we can still see the blue. Now what you should see is about the same height in here, right? This is red, this is red. Here's our yellow, here's our yellow. That's just telling you the energy of it. So that's why we see the lines lining up here. It's just that these are now all pulled closer. Whoop, really close if I do it that way.
Now I got some Mercury. Here's Mercury with the glasses off. Here's Mercury with the glasses on. Love that purple and blue color. Oh yeah. Looks real nice.
Probably should see a different barcode even more on this one.
Oh yeah. Different barcodes for every element.
So now the next sample that we're going to do is what is mostly the most of the air is comprised of. That is nitrogen. So here is nitrogen with the lights or the glasses off. Here's nitrogen with the glasses on.
What a beautiful spectrum. My goodness.
It's a good spectrum.
Great spectrum. That's one thing we all know about nitrogen. It's a great spectrum.
For our last gas that we're going to put in here, we're going to use some argon. Here's our argon without the glasses and our argon with the glasses. Again, we should see a nice spectrum. Each one of these should be different for all 6 of the elements. This is how we do spectral analysis of so many different kinds of chemicals here on Earth as well as out in outer space.